So, good evening everyone. So far it has been a long day. I'm very happy to see you all coming to share some science with us, and welcome to our symposium on new insights on diet and health. I'm Petra Klaassen-Wigger. I am a scientific advisor at the Nestlé Research Organization, or Research and Development Organization, and I'm very much welcoming you to our session today. So we want to take a fresh look on what is actually the evidence that we have and how can we build a future on that, connecting food and diet and health. So we have three exciting speakers with us here that will cover various aspects, and we will start today with Professor Regan Bailey. Professor Bailey is an Associate Institute Director for the Institute for Advancing Health Through Agriculture and Professor of Nutrition at the Texas A&M University. And her research focuses on improving methods of measuring nutritional status to understand how dietary intakes relate to health. So that is what we thought was a very good starting point for setting up the scene and having a presentation on revisiting the impact on health from nutrients to diet. Regan, please.
Thank you so much, Petra and Nestlé, for sponsoring this session. I'm sorry, I have a little bit of a head cold. It's not COVID. I've tested myself several times. So again, we're just going to go through a really quick history of how we as a field have looked at dietary exposures and how they relate to health outcomes. Maybe we are, maybe we aren't. Okay, there's my disclosures. Not much relates to this topic. So the first vitamin was discovered or isolated in 1926. So who knows what that is? Raise your hand. This really isn't working very well. Does anybody know? Hannah, what was the first vitamin ever isolated? That's right, it was vitamin B1. So if you think about 1926, there were, okay. So 1926, that's not that old of a science. And so the field of nutrition is often criticized because one day you say coffee is good, coffee is bad. But if you look at other types of science, they're much, much older than that. And so that discovery and isolation of micronutrients led to fortification and enrichment practices that really reduced deficiency disorders in our country. In many countries of the world, deficiency disorders are still very pervasive. In the United States, unless there are generally extenuating circumstances, we've largely eradicated the major deficiency disorders. And so then we began to think about how can we focus from deficiency to health. And so I have a picture here of Johanna Dwyer, who was an intern on Capitol Hill for the first White House Conference in Nutrition. And if you ever heard the name Johanna Dwyer, raise your hand. Okay, except for you guys, everybody should know Johanna Dwyer, okay? At her retirement ceremony, they said there's only three women in the world who don't need last names: Cher, Madonna, and Johanna. So when most of you weren't even born yet, when she was thinking about how we transform nutrition to make people live healthier lives. And so once we got people on board, then that's where chaos starts to ensue. People started to argue. Is it high fat? Is it low fat? Is it vegetarianism? And so these are just a couple of pictures of the big players in the field. I had a cup of water right here. Okay, so my very first experimental biology meeting, it was a packed room, and it was Dr. Atkins, Dr. Ornish, Gary Taubes, Barbara Rolls, and they were all fighting, screaming about what was the right combination of macronutrients that were going to prevent obesity. Again, raise your hand if you think we've prevented obesity. So that's my point here today, is nutrition is iterative. We learn things, and we now know that not everyone responds to the diet in the same way. And during the same time, people like Barbara Rolls were also studying eating behaviors. Rick Mattis was looking at sensory science. It's not just how we eat, but it's the properties of food. How does it taste? How quickly can we chew? All of these other things that he studies. We discovered leptin, and by we, I mean not me. That guy on the far right discovered leptin. So leptin, in theory, all of these things led to a time where we should be able to stop or prevent gaining weight and having excess problems of obesity in our country. During this time is also when we realized how important nutrition was and started developing dietary guidelines. So I don't have to talk to anyone in this room. Obesity leads to diet-related chronic disease in and of itself, but also other cardiometabolic problems. So at a time where life expectancy should be increasing, for the first time, we're starting to see a slowing of that trajectory and actually a decrease in some point. So I had diet as a solution, and I was talking with some people right before this meeting, and then I wrote, but GLP-1s. So there are now, it's like we now have all this traction for why nutrition is so important and why we are getting better at science and how we're having better trials at the same time that we now have medications. We always said there's never going to be a magic pill for nutrition. Well, for a lot of people, GLP-1 agonists are a magic pill, and how we deal with that as a field of science, I think this is worthy of a conversation. But back to the story, back to my timeline, moving from hunger to health. So as we've largely eradicated deficiency disorders, how do we optimize diet and our recommendations that we make to people to make them as healthy as we can? And so this is a hypothetical distribution based on the National Academy of Medicine framework, but it's showing that there's variation in a distribution around requirements for nutrients and food components. So that's very specific. You should have this much calcium plus or minus. You should have this much vitamin C. To reduce your risk of hypertension or heart disease, you should have sodium less than or within this band. So that's nutrient by nutrient, or what we call a reductionist approach. And we don't eat nutrients. Who went to dinner tonight and just had a plate of calcium with a side of niacin and a little bit of folate? Did anybody have that? No, we eat foods. Foods are a rich combination of lots of nutrients and things that we don't really know about that are in the diet. But what we do know, based on years and years of dietary guidelines from the 1980s, is that dietary patterns that are aligned with the dietary guidelines reduce the risk of those chronic diseases related to dietary intakes and reduce risk of all-cause mortality. But it's not that simple. So this is just looking at every 5 years how our dietary recommendations change for consumers and the messaging that we give to them. So you'll see in 1980, we had 7 very concrete, simple messages. In the last iteration of the 2020 dietary guidelines, which I was painfully involved in, I'm still experiencing a little PTSD. It was the chapter that I led was over 100 pages of single-space text, because nutrition evolves, and it's evolving so quickly, and it's because people like this, people at this meeting who are doing research, and we're just trying to figure out what we can do to help advance human health. And so it's not as simple. But at the same time, if you look at those 7 messages, it's still a lot of the similar kind of constructs. Dietary variety, eat more fruits and vegetables. So as much as we are getting more iterative, there are still some hallmarks that I think we can hang our hats on. But on a scale of 0 to 100, report card, healthy eating index, how well American diets align with those recommendations that we know are related to reduced risk of poor health outcomes and even death, most Americans are not following the dietary guidelines. And that's because only about half of them know about the dietary guidelines. So this is consumer data coming from IFIC, the International Food and Information Council, who has done a survey for 20 years asking consumers various questions, but they track trends over time. And as scientists, we often looked at the world very, very differently than consumers do. And that's why I love working with this organization, because it's a completely different perspective than we're used to seeing. But one thing that has been consistent over those 20 years is people are not choosing a dietary pattern because they're trying to protect their health. The top two reasons are because it tastes good and I can afford it. Healthfulness and convenience are starting to become tied for third. So we look at the world like everybody wants to eat better because everybody wants to have better health. That's not the way that consumers eat. And again, another slide from IFIC. This is showing dietary patterns or eating patterns that people report that they are identifying with. So high protein, mindful eating, intermittent fasting. But as researchers, this is a very busy slide, but as researchers, we take dietary data and make it very complex. There's all these different types of algorithms we can use to figure out dietary patterns, whether we start, top down from the data from what people are eating to a health outcome, or bottom down on the right, or reduced rank regression and CART, that looks at a health outcome and then how we explain the variation in that. We make this really complicated when people are just saying, I follow high protein. So understanding and meeting consumers where they are, I think, will be kind of the future of where we're going. So that's where I think the real opportunity is. But we need better ways to characterize dietary exposures. We all know that self-reported diet has measurement error. And we want to really get from exposures to that health outcome. There is right now this gigantic black box between what you had for dinner, what you normally have for dinner. We don't just want a one-off, right? We want habitual or usual intakes, and how that exerts its metabolic response and in turn influences a health outcome or disease state. And so that's kind of where we are coming from. We still care about all of these things, but if we look at them in totality, I think that's where we're going to advance. So just as we've not looked at one food or one nutrient, what we're working on now in our lab is patterns of nutrients in other bioactives. So I always joke that when you're in polite conversation, you don't talk about politics, religion, or dietary supplements, but everything that I do is on dietary supplements, and I'm not usually known for polite conversation, so I'm okay with that. And that's because more than half of adults and 1/3 of children use a dietary supplement regularly. And most often, it's a multivitamin, multi-mineral product. And so people aren't just using one. So 40% of adults are using one product, but 10 or more % are using 5 or more products every day. And so if you're looking at the relationship between a dietary exposure and a health outcome, and you're not accounting for all of the nutrients and bioactives from these exposures, you're really going to have a problem with classification. And so Dr. Cowan in my lab and I have been working on what we call a total nutrient index. So just like the Healthy Eating Index, which measures dietary compliance to the dietary guidelines, our index, and these are selected vitamins and minerals based on the dietary guidelines, we look at how well usual intakes for a specific nutrient meets the dietary reference intake recommendation. So you can look at this either as a component, just like you could look at what is your fruit score? Is your fruit score high or low? Is your calcium score high or low? But we also have an average of that, similar to the HEI, 0 to 100. So I'm not ever trying to replace the HEI, but to be used in conjunction with it to account for those large number of people who are using these products. And so this is a radar plot. If everybody was in perfect compliance, the lines would be around the outside of that kind of what I think of as a spider web. So on average, you can see the component scores in black. And what's interesting is you can see for nutrients like vitamin D, where a large amount is contributed from supplements, this is the average. But for users, their score is 81 out of 100. For people who don't, their score is 30. That's a really big difference. So this tool gives you, as a researcher, an opportunity to look at use and non-use. And we picked these nutrients based on the 2015 guidelines when we developed it, but it can be used and tailored to any nutrients of interest. When we were trying to validate this, we look at people or groups who we know have different diet quality. And so we see that smokers and non-smokers have a different TNI score. Those who are food secure and those who are not food insecure or not food secure have very different scores. And so again, not trying to replace any indices that are out there, but trying to be complementary of that. And importantly, it improves the correlations between dietary exposures and biomarkers. We do not have very good biomarkers in the field of nutrition that represent status. So if we can account for those, these are still not great correlation coefficients. I'm not gonna lie. But 0.08 is better, or 0.2 is better than 0.08. So we're getting better. Again, we're iterative. Nothing here is perfect, but we're getting better. We're thinking about it. And we just had the grant, we just resubmitted it, it was awarded. We have looked at these TNI scores and how they relate to risk of all-cause mortality, and our preliminary results indicate that higher scores on the TNI predict death. And this is from data from the National Health and Nutrition Examination Survey, so this is nationally representative survey data linked to the National Death Index. So this is not a small cohort study. This is the United States. This is all of us in this room. And so what the next step is really, we know dietary exposures are important. They are related to health. How do we measure them? This is really where the break in the knowledge is. We have those biomarkers, but how do we get from here to here? Not that reductionist approach that we started with dietary research. We need something better. And so this is kind of like, I'm a joker, so, sometimes I put slides in and then I don't mean to keep them in. Being simple is sometimes helpful, but not in this case. We need a complex integrated biomarker of nutritional exposures that can be used and validated to relate exposures to a health outcome. And so this is a quote from the Harvard group, and I am totally remiss in not putting the reference down here. It's from Frank Hughes' group. I say omics or fomics because there's this fear that if you're not doing something in omics, you're going to be missing out on nutrition. The omic technology has potential. We have not actualized that potential. And it's not this versus that. It's never us versus them. It's can we integrate this omic data with dietary data to get a better algorithm to predict response. And so I always say progress versus perfection. I think we not only need to measure what people are eating, but we need the social context. How often are you eating? What is the timing? What is your food purchase behavior? We eat for a lot of reasons. Like I said, you don't just sit around and eat a plate of nutrients, right? You eat with your family, maybe. You eat with your friends. It's a cultural experience for you. Maybe you have access to a stove and you can cook food. We have to measure all of these things, not just looking through our nutrition lens, but through all of these other factors that modulate the way that diet impacts health. And so I think these are my last two slides. We have, and I have for the most of my career, worked at population nutrition level. We tell everybody to eat the same thing. When you work with a dietitian, they look at you. You, Petra, you eat this. This is what you need. But now we're in that interface and of precision nutrition where maybe a group of you are at risk for heart disease, and I can give you more actionable items than between everybody eat this way and one-on-one kind of communication. And so there's a lot of research needs, and I think that gives us all not only job security, but it gives us something to think about in terms of the way that we all look at our own research questions. So we definitely need better measurements of dietary exposures through dietary assessment. We need to leverage omic technology and other biomarkers to understand that black box between what people are eating and how it exhibits a health response. And we can use technology, so biomarkers, sensors, wearables, there's all kinds of technology. It's just getting the right people in the room to work together towards that end. And the Nutrition for Precision Health Initiative at the NIH is doing just that. I definitely did not mean to leave "Don't jump the shark with haterade" for dietary data in there. But my point is, everybody wants to say dietary data is so bad. If you measure anything, there is error. Blood pressure, anything you measure has error. Where the beauty in that is that oftentimes the errors are uncorrelated, and that's when they can be leveraged to work together. So the omics error is different than the dietary error, and that's why you're able to leverage them. And again, I talked about multidisciplinary teams. And then databases. Nobody thinks databases are sexy. It's not something fun everybody wants to talk about, but we only know a fraction of what is in the foods that we eat. It's not just nutrients and bioactives, and there's environmental contaminants, there's pesticides, there's all kinds of things in foods that we do not have a very good database for. So I'd just like to thank my team and thank you for your time.